Proportionality questions are questions concerning the relationships between physical quantities. These questions are often phrased in terms of how changing one quantity will affect another. For example, consider the question, if you double the voltage, the potential difference supplied to a circuit, what happens to the current flow? You could look at the equation from Ohm's law. The current I is equal to potential difference, or voltage V, divided by the resistance in the circuit, R. From the equation, you can see that if the voltage doubles, the current will also double. If you don't like the abstraction of the letters in the equation, turn those letters into numbers. 1 amp is equal to 1 volt divided by 1 ohm. If you change the voltage to 2 volts, you then have 2 volts divided by 1 ohm, or 2 amps. We can represent the relationship between the current and the voltage as I fishy V. That fishy is read as proportional to. In this case, current is directly proportional to voltage. When you change the voltage, the current changes by the same factor. To turn an equation, such as the one for Ohm's law, into a proportionality, just set everything else in the equation, such as the resistance, equal to 1. If you want to show the relationship algebraically, say you're writing this out for a problem set, you could show this by setting your initial current I1 equal to V1 over R, your final current I2 equal to V2 over R. Notice the resistance in each equation is the same because resistance is constant. It is our controlled variable. You then replace the V2 with 2 times the V1. Factor that 2 out the front, so you have rearranged the expression until a part of it equals the original. Substitute in the original. V1 over R is equal to I1, so I2 is equal to 2 times I1. That's the algebraic way of looking at it, given the equation. If you didn't know the equation, how could you answer the question, if you double the voltage supplied to a circuit, what happens to the current, experimentally? Well, you'd set up your circuit, change your voltage, that would be your independent variable, measure your current, that would be your dependent variable, and graph your data. Take a moment to think about what the graph for that data would look like. If you change the voltage and the current changes at the same rate, you should get a straight line graph. This is a linear relationship. Now, you can also ask, what is the slope of that line? Until you determine the relationship between current and all other possible variables, we can just call it K, the proportionality constant. To turn a proportional relationship, I fishy V, back into an equation, just put in the K there. In this particular example, K should be equal to 1 over your resistance, whatever that was set at. Let's look at that resistance. Consider now the question, if you double the resistance of a circuit, what happens to the current? In this case, current is inversely proportional to resistance. When we set everything else in the equation, that V equal to 1, the resistance stays in the denominator there. You want to show this algebraically. This time, voltage is the controlled variable. Change your resistance. Factor that 2 out the front. It stays in the denominator, so that if the resistance is doubled, the current is halved. I2 is 1/2 of what you had before. The graph for that relationship would look like the curve shown here. This is a rectangular hyperbola, or 1/2 of it at least. Notice that it does not intersect either axis. The axes are the asymptotes of the hyperbola. Now, that curve may look familiar. It may look a lot like the inverse square laws that we've seen before. How do we know it is actually 1 over r and not some similar relationship like 1 over r squared? And what's the proportionality constant k? How can we get a slope when we have a curve? We change the curve to a straight line. We graph I on one axis versus 1 over r on the other axis and see if it's a straight line. Yes, this would mean you would need to change all of your data values for your independent variable. You would then have a proportionality constant k. In this case, k is equal to V, the voltage. If it is actually an inverse square relationship, the first regraph versus 1 over r will not get you a straight line. You have to keep graphing until you get a straight line. It is also possible that the curve could be an inverse root. You can also try graphing a quantity versus the inverse root of the other quantity. It's also possible that you can see curves that look like parabolas. For example, if you were measuring the distance delta d an object travels while accelerating from rest in some time delta t, you should get a curve that looks like half of a parabola. Regraph delta d versus delta t squared, and you'll see your straight line. The slope of that straight line should be equal to 1/2 times your acceleration. If you see a curve that looks like a parabola on its side, you can either square the quantity that's on your vertical axis or take the square root of the quantity on your horizontal axis. If you can't tell which kind of curve you have, then it's time to increase the range over which you're taking your data.